All right, so now that we've learned how to solve our polynomial inequalities, now we're going to talk about how to solve our rational inequalities. So a lot of this is similar to what we did in our polynomial inequalities. But when we do our rational inequalities, we need to talk about what x is, so what are the x-intercepts, as well as what x cannot be. Sorry, I have the hiccups. So if we look at the top, our x-intercept here would be -1. And then if we looked at the bottom, we would have a vertical asymptote at x equals 2. So x cannot be 2, right? The domain, x cannot be 2. So these are two numbers that have to be on our number line. So x can be 1, x cannot be 2. So when we go to our symbol here, because it's an or equal to, at -1, we're going to have a closed circle. And then at +2, we would think that because this is underlined, we would also have a closed circle, but this is saying that x cannot be 2. So even though this is or equals to, this still has to be an open circle. Now from here, we're still going to do the same thing. We're going to plug in a number in each interval and see if we get positive or negative. So if I plug in -2, I've got -2 plus 1 over -2 minus 2 would give us a negative divided by a negative, which would give us a positive. Excuse me. If I plugged in a number here, 0, let's say, 0 plus 1 over 0 minus 2 would be a positive over a negative, which would be a negative. Then I could plug in 3. 3 plus 1 over 3 minus 2 is going to give us another positive. Now if we look, it says greater than or equal to 0, which means we want the positives. So our answer is going to be -∞, -1 with a bracket. And then 2 has to be a parenthesis because it's an open circle. So we've got a bracket with our -1, parenthesis with the 2. Infinities always have a parenthesis. Okay, in number 2, we're going to have to factor first. So we have to ask ourselves what multiplies to -10 and adds to 3. So x plus 5, x minus 2. So x can be -5 and -2. X cannot be 3. So we're going to go to our number line. Because this is an or equal to, at -5 and -2, we're going to have closed circles. And then at +3, it's going to be an open circle because it cannot be 3. Plug in a number into each of these, find out if it's positive or negative. I would suggest plugging it into the factored. So -6 plus 5 times -6 minus 2 over -6 minus 3. This would be a negative times a negative, which would give us a positive, over a negative, which would give us a negative. It's a lot easier than plugging it into here. I'd plug it into here. So go ahead and pause and find our positives and negatives in each of these. Okay, so because we want it to be positive, we're going to be here, here, and here. So we could say -5 all the way to 3. And then 3 to infinity. Sorry guys, we're allowed to skip over this 2 because it's a closed circle. If it was an open circle, we would have to stop here just like we stopped at the 3. Okay. Okay, number 3. First we have to factor. So x equals 4 and -3. X cannot equal -5. So now when we go to our number line, what we have to do is be careful. Because this is strictly less than and not less than or equal to, these technically can't be equal as well. So on our number line, -5, -3, and 4 all have to be open circles. Because it's strictly less than, none of them can be closed circles. Okay, then we're going to pick one in each of them, plug it in, and try. So I'm going to let you guys finish this one on your own. Check the answer key, try this one, check the answer key. Okay, number 6, we've got 4 over x plus 6 is less than or equal to 5. So the first thing we have to do is make this 0, so we're going to have to subtract the 5 over. So we've got 4 over x plus 6 minus 5 is less than or equal to 0. Now I can't figure out what x equals and cannot equal until this is one fraction, and in order to make it one fraction, I'm going to have to subtract, which means I need common denominators. So I'm going to have to multiply this one by x plus 6 on top and bottom. So that gives us 4 over x plus 6 minus 5x plus 30, if I distribute this 5x over x plus 6. Now that we have common denominators, we can make it one fraction. But make sure you're careful. So we have 4 minus 30 would give us negative 26. And then we have minus 5x. So now that we have one fraction here, we can say what x equals and what x cannot equal. So x cannot equal negative 6. For this one, if you can do that math in your head, awesome. If not, remember you can just set it equal to 0. So we can say negative 26 minus 5x equals 0. Add the 5x to the other side, divide by 5, we get negative 26 over 5. So on our number line here, we've got negative 26 over 5 and then negative 6. Okay, well, if you think about it, negative 25 over 5 would be 5, so this is a little bit more than negative 5. So I really should have put this as the negative 6. And the negative 26 over 5 would be here, right? Because this would be like negative 5 point something. So I got more negative to the negative 6. The negative 6 has to be an open. The negative 26 over 5 has to be a close. Then you're going to pick a number in each of the intervals and test them out. Okay. I'm going to let you do that. Check your answer on the answer key. Number 7, same thing. First thing we have to do is subtract this to the other side. So that gives us 2 over x minus 1 minus 3 over x plus 2 is strictly greater than 0. Now we need common denominators. So we need to multiply this one by x plus 2 on top and bottom. And then we need to multiply this one by x minus 1 top and bottom. So then this would be x plus 2, x minus 1. Distribute 2x plus 4 minus, same thing, x plus 2, x minus 1. And on the top we've got 3x minus 3. Now that we have common denominators, we can set it up together. So x plus 2, x minus 1. So we've got 2x minus 3x would be negative x. And then 4 minus negative 3 minus a negative is going to turn to plus, right? So plus 7. So x equals, if I set this equal to 0, I would subtract the 7, then divide by a negative, so that's going to be positive 7. And then x cannot equal negative 2 or negative 1. So then on my number line here, we're going to have negative 2, negative 1, and 7. Now it cannot equal negative 2 or negative 1. And in this case, it also cannot equal 7 because it's strictly greater than, so they all have to be open circles. So, just like the other ones, finish finding your positives and negatives, write your answer, and then check your answer on the answer key.